Assalamu alaikum. Hello students. Today we have to solve problem number 2.7 of Electrodynamics 4th edition by David J. Griffiths. In this problem we have been asked to find electric field at some point P at a distance z from the center of a uniformly charged spherical shell having uniform surface charge density sigma. To find our required field at this point P, we will divide this complete shell into coaxial loops. That means all the loops will have same axis, or in other words, all the loops will have their centers on the same line. Now, one of those loops have been shown here. Now, first of all, we will find electric field at this point due to this loop. And then finally, we will integrate that loop across this complete shell to get our required field at this point. Now, in our problem number 2.5, we derived an expression of electric field due to a loop, and that expression came out to be this. Now, we will modify this expression. We will modify this expression of electric field for this loop to get electric field due to this loop at this point P. Now, the electric field of this loop will definitely be denoted by dE, because we are well aware that here in this case this loop is behaving like a charge element, and we know that the field produced by charge element is always denoted by dE. Now, the field produced by this charge element dE will be equal to, by using that expression, we get K will be written here as it is. This Q will be replaced by dQ. Why? Because this loop is behaving like a charge element, and we know that amount of charge of a charge element is always denoted by dQ. Now, what is Z here? Here in this case, Z was actually the distance of point P from the center of the loop. Now here, what will be the distance of this? What will be the distance of center of this loop from this point P? The center of this loop is somewhere will be at this point. Now this is the distance from this. That will be the distance. That will be the distance of center of the loop from this point P. How will we find that? How will we find this distance? First of all, we say that this angle is theta. This angle has been denoted by theta, and this length is actually the radius of this spherical shell, and that radius has been denoted by r. Now this distance will be r cos theta, okay, and the complete distance from the center of the shell to our point in question, this complete distance is denoted by capital Z. That's why this remaining distance will be equal to Z minus r cos theta, okay. So this Z is replaced by Z minus r cos theta. Is it clear now? Here in this case, this Z was actually the distance of point P from the center of the loop, and here in this case, the distance of the center of the loop from this point P will be this distance, and that distance will definitely be equal to Z minus r cos theta. That's why I replaced this Z by this term, by this quantity here. Now in the denominator, r square. What was r here in this case? R was actually the radius of that loop. But what will be the radius of this loop here in this case? That radius is definitely this length, and that length will be equal to by using this right triangle, we get this length as r sine theta, okay. So this r will be replaced here by r sine theta, and that square will be written here as it is. Again z, what is z? Z minus r cos theta, we have just calculated, z minus r cos theta, and square will be written here as it is, and whole power 3 by 2 written as it is. Is it clear? Now in the next step we will replace this dq by what? K z minus r cos theta, and this dq, what will be this dq? dq is actually the amount of charge on this loop, and we know that the charge density of this loop will also be sigma, and that charge density, if we calculate, will be equal to the amount of the charge on the loop divided by area of the loop, and area is always length multiply width. Now what will be the length of this loop, or in other words, what will be the circumference of this loop? That circumference will be equal to 2 pi multiplied by its radius. And what is its radius? Its radius we have just calculated is r sine theta. Okay, this is the radius, this is the radius of the loop, r sine theta. So 2 pi into r sine theta, this term provides us the length of that loop. Now we have to multiply this length by the width of that loop to get the charge density of this loop. Okay, now what will be the width of this loop? The width of this loop will be something, this arc length, okay, and this arc length has been denoted by s, and that s will be equal to r multiply angle contained by this loop, sorry, angle contained by this arc length. And what will be the angle contained by this arc length? This one is the angle contained by this arc length. Let me show here. Okay, now this is the angle contained by this charge element, and that angle has been named as d theta. Okay, so our complete arc length came out to be r d theta, and definitely that will be the width of our loop. So I multiply it by r d theta. So this is the charge density of that loop. Now if I separate the value of dq from this expression, I will get here sigma into 2 pi r sine theta, and r multiply r, it becomes r square, 2 pi r square sine theta into d theta, and whole divided by the terms in the denominator will be written here as it is, our z minus r cos theta whole square and whole power 3 by 2. So this is the electric field. This is the electric field produced at this point P due to this loop. Now, in order to get our required field due to that complete shell, we will integrate this field across our complete shell. Okay, now let's see. Okay, now let's integrate this expression to get our required field. If we integrate both sides, then definitely that dE will be converted into E, and E will what is E? E is electric field produced by that complete shell. So E will be equal to what? 2 pi sigma r square into K integration, and now we will write here z minus r cos theta into sine theta d theta whole divided by r sine theta whole square plus z minus r cos theta whole square and the whole power 3 by 2 written here as it is. Now let's simplify our denominator and see what happens. I have shortage of space here. That's why I'm gonna remove all these writings. So let's see now. Okay, now let me simplify this denominator. Now E will be equal to 2 pi sigma r square into k. All these terms were actually the constants, so have been written outside the integral. Okay, integration now z minus r cos theta into sine theta. That means the numerator has been written as it is, and now let me simplify this denominator. It becomes r square sine square theta plus z square plus r square cos of square theta minus 2 z r cos of theta and whole power 3 by 2 written here as it is. In the next step, it becomes all these terms outside the integral will be taken here as it is, and numerator also written here as it is into sine theta d theta. In the denominator, these terms, if combined, this one and this one, if these two terms combine, taken r square common, it becomes r square, because we know sine square plus cos square equal to 1, plus z square written here as it is, and minus 2 z r cos of theta whole power 3 by 2 written here as it is. Okay, now here in this case our variable is theta, so let's see what will be the limits of integration. Now I'm telling you how the limits of integration will be decided. If I take this loop at this corner, there are two possibilities. There are two extreme possibilities for the position of the loops. The loop may be somewhere at this corner or maybe at the other end, and if I move the loops from this end to other end, definitely it will cover the angle of 180 degree, the angle of pi. So the lower limit will be 0 and upper limit is pi. So lower limit 0 and upper limit is taken as pi. Okay, now let us convert this theta variable into some like algebraic variable, into u variable, t variable, x variable, or something like that. Now let's see how will we convert it. Okay, now let's see how will we convert this theta variable into u variable, and why we are doing that? For integration purposes. Okay, if we convert this theta variable into u variable, then definitely integration will get simple. For this purpose, let me put here cos theta equal to u t x, whatever you want. So if I put cos theta equal to u, then definitely by taking integral on both sides, we will get minus sine theta into d theta equals to du. And one thing more, if we convert this theta variable into u variable, then definitely the limits of integration will also be changed. Now let's see what the changings will be made here in the limits of integration. If theta is equal to 0, then u equals to what? If I put theta equal to 0 here, then definitely cos 0 equal to 1 and u will be equal to 1. Okay, and if theta is equal to pi, then what will be u? Here, then u will be equal to what? If I put here theta equal to pi, then cos pi equal to minus 1. So u will be equal to minus 1. Now let us use these substitution here in this integral and see what happens. Now e equals to 2 pi sigma r square k, and limits of integration will be changed, will be replaced by 1 to minus 1. 0 will be replaced by 1 and pi will be replaced by minus 1. The reason is in front of you. Now in numerator it becomes z minus r u, and sine theta into d theta will definitely be equal to minus du. Okay, that will be equal to minus du, and denominator becomes r square plus z square minus 2z r, and cos theta has been replaced by u, and whole power 3 by 2 is written here as it is. In the next step, let's see what happens in the next step. Okay, in the next step, by removing this negative sign, these limits of integration will be replaced by one another, and it becomes e is equal to 2 pi sigma r square k, and these limits of integration will be replaced by one another, and this negative sign is removed. Z minus r u into du divided by r square plus z square minus 2 z r u whole power 3 by 2. Okay, it's your own choice. You can use either u or x or t or something else, but don't use the alphabets have been used here in this integral already. Okay, now in the next step we have to find the result of this integration. Definitely that integration is much long. I'm not doing here, but I'm giving you the link of the PDF of this integration in the description below. You can get that integration from the description. The link has been given below. Okay, now I'm directly writing here the result of this integration. Now let's see what is the result. Okay, now this bracket gives the result of our integration, while these terms were outside the integral. Okay, now this is our final field in general, but here in this problem we have been asked to find electric field for two cases. The first one, if our point P lies outside this shell, or in other words, if this distance z is greater than the radius of this shell. And the second case is if our point P lies inside the shell, or in other words, if the distance z is less than the radius of this shell. Let's see both of these two cases. The first case, case number 1. If distance z is greater than r, or in other words, if our point P lies outside the shell as shown here, or if P lies outside the shell, outside the shell. Okay, now if this distance z is greater than r, then our expression is modified as 2 pi sigma r square k, and this z square minus r square over 2 r z square is written here as it is. And now if z is greater than r, then definitely this mod function will be expanded as r minus z with negative sign outside. Okay, r minus z with negative sign outside the bracket, and 1 over r plus z definitely will be written here as it is, and again 1 over 2 r z square will be written here as it is, 1 over 2 r z written here as it is, and again once again this mod function will be expanded as r minus z multiplied by this negative sign, and again the next bracket will be written here as it is. Now we just need to simplify this whole expression and see what does it give us. 2 pi sigma r square k is written here once again as it is, and now z square minus r square divided by 2 r z square once again written here as it is, and if we take square root inside the bracket, it becomes r square minus z square with negative sign. Okay, or let me solve here in another way. R square minus z square is written here as it is, and this negative sign is shifted up here, and it becomes negative of r plus z minus r minus z. That's simple mathematics, you are aware of that. Okay, and after negative sign once again 2r z square is written here as it is, and if I multiply this negative sign here inside, it becomes negative r minus z negative r minus z. And now in the next step, what does it becomes? It becomes 2 pi sigma r square k, and you can see here that if I cancel this r minus z square by this z minus r, then definitely we will have a negative sign here, we will have a minus 1 here, because r minus, this is r minus z square and this is z minus r square. So if I want to cancel out these two terms, then I will have to take negative sign common from this expression, from z square minus r square. Okay, so in this way, if I cancel out these two expressions, I will get here a negative sign, and in the next step it becomes this negative sign is written here as it is, minus 1 divided by 2 r z square. Now if I multiply this negative sign inward, it becomes minus r minus z minus r plus z. Okay, and in the next step it becomes what? Minus 1 divided by 2 r z square, and again sorry, I made a mistake here. Yeah, I made a mistake here, this is positive z. Now plus z minus z cancelled out, and we get here minus 2 r. Okay, in the next step also these two terms will be cancelled out, and it becomes 2 pi sigma r square k. Now it's pretty clear that I can take this minus 1 by 2 r z square as common, so I'm taking it. Minus 1 divided by 2 r z square has been taken common, and now it becomes minus 2 r, it becomes minus 2 r, and that one is plus 2 r. Now let me solve it further. Sorry, I made a mistake here, that we will have here minus 2 r, not, it is not plus 2 r, it is minus 2 r, it is minus 2 r. How? Because I have taken this minus 1 by 2 r z square and minus 1 by 2 r z square as common. Okay, so in the next step this negative sign will be taken here as it is. Hope it's clear. Now let me simplify it more. Okay, I didn't remove here the last term. Okay, now let's see what does it become. Now it becomes E is equal to 2 pi sigma r square k, and once again minus 1 divided by 2 r z square taken here as it is, and now it becomes minus 4r. And in the next step, it's pretty clear that 2 and 2 have been cancelled out, negative multiply negative becomes positive, and finally it becomes 4 pi and another thing, that this r and this r also has been cancelled out. Now it becomes 4 written here as it is, pi written here as it is, r square written here as it is, sigma as it is, this k as it is, and z square in the denominator. Now what do you think that what does this expression tells us? What does this expression tells us? This one, what does this expression tells us? It is actually the charge on our complete shell. How? This is the charge density of our complete shell, and if I separate here the value of q from this expression, it's pretty clear that q will be equal to 4 pi r square into sigma. Okay, because this 4 pi r square is actually the complete area of that spherical shell. So if I multiply this area by charge density, we will get the complete charge contained by that spherical shell. So this expression, this complete expression, gives us the whole charge contained by our shell, and it becomes kq divided by z square. Now what is this? It is actually the electric field due to a point charge. Electric field due to point charge. What does it mean now? It means that for all the external points outside the spherical shell, our shell behaves like a point charge for all those external points. Hope it's clear. Now let's see our next case, that if our point P lies inside the shell, then what happens? Let's see that. Okay, now let's see, if point P lies inside the shell, then definitely in that case the distance z will be less than the radius of the shell. Now again we will use this equation that was the general electric field due to that spherical shell. Now E is equal to 2 pi sigma r square k, and this z square minus r square over 2 r z square will be taken here as it is, and now this mode function, the terms inside the mode function will be taken here as it is, as they are, and mode sign will be removed. That's simple mathematics, you are aware of that. Minus 1 by r plus z written here as it is, minus 1 divided by 2 r z square, and again this mode function has been expanded, and it gives the result as r minus z minus, and this negative sign has been multiplied inside, and it gives us minus r minus z, and this whole bracket. Now 2 pi sigma r square k, again written here as it is, z square minus r square 2 r z square, and if I take LCM inside, it gives r square minus z square, and here it gives the result r plus z minus, and this r minus z will be multiplied here and will definitely become minus r plus z, and after negative sign 1 by 2 r z square, again it gives the result, these two terms have been cancelled out, and we get here minus 2z, and bracket closed. Once again I can cancel out these two terms. this one and this one. But again, if I cancel these two terms, I will get here a negative 1. So in the next step, it becomes 2 pi sigma r square k and minus 1 over 2 r square z, and once again these two terms have been cancelled out, and we get here 2z divided by what? Nothing. 2z written here as it is, and again minus 1 by 2 r z square taken here as it is, and minus 2z taken here as it is. Once again, if I take these two this expression as common, I will get here like 2 pi sigma r square k into minus 1 over 2 r z square, and we are left with 2z minus 2z inside the bracket. Now these two terms will cancel out each other, and then we will get that is equal to 0, because if these two terms are cancelled out, we have 0 inside this bracket. Now this 0 by multiplying all these terms makes it 0. So the net electric field is 0 inside the shell. Okay, so a uniformly charged spherical shell does not produce any electric field inside it. It does not produce electric field at any point inside it. Electric field inside it will be 0 for all the points inside the shell. Hope it's clear. In the next problem, the next problem is 2.8. So let's see in the next video. Goodbye.